Hi, I'm Coach Cowland, and in this presentation, we're going to look at speed and velocity. We're going to be covering distance, speed, average and instantaneous speed. We're going to look at what they are and how they're different to each other, displacement, velocity, and the units of speed and velocity. So, first thing to do is ask ourselves, what is speed? And one thing that we could do to answer that question is look at what we need to measure the speed of something. And typically, to measure the speed of something, you need to know a length. You need to know how far it's traveled. The other thing you need to know is the time it took. So that gives us a really good indicator of what speed is and how to go about defining it. You might just say, as a general definition, speed is how fast something's going. So that's a pretty good layman's term definition of what speed is. But we need to be a little bit more specific here. So maybe we could look at it mathematically. We use a lot of math in physics, so we could say it's a ratio of the distance traveled and the time taken. So that's a pretty good mathematical definition. So let's take this one step further and make it into a physics definition, shall we? And we'll say it's the distance an object travels in a given amount of time relative to a point. Remember, the first presentation was looking at relative distances. And this is, as we saw, very significant. So relative to a point, it's the distance the object traveled in that given amount of time. Of course, all three definitions are correct. It's just the one that we need is best for us is the third one, which is most specific. So when we look at the distance is pretty straightforward in terms of a definition. It's the length of the path traveled by an object. So the blue circle travels a distance x, and that's the distance. Now, what I've written here is the length of a path traveled by an object either in one direction or in another. So here we have the same object and it moves in one direction to x and then back again. The distance traveled is the sum of the two distances combined together. Seems pretty straightforward, right? Good. Okay, so if we were to find an equation for the average speed, we would say the average speed in meters per second, that's our SI units there, is the distance traveled divided by the time taken. So average speed is equal to d divided by t. Instantaneous speed is a little different. The instantaneous speed is the speed an object is traveling at a particular instant. Now this is kind of like taking the time taken and making it infinitely small. It's something that you would do if you were doing calculus, but we're not going to go into that. Now, an example of how they're different is if you were on a road trip and you traveled 100 miles and it took you 2 hours to do, you would say your average speed was 50 miles an hour. But if you look at the odometer at any particular instant in your journey, you might see that your speed at that instant is never actually exactly 50 miles an hour. It might be something completely different. It might be 70 miles an hour when you're on the interstate or 35 miles an hour when you're just approaching the place where you're going to because you're in a uh, because there are houses nearby. So the instantaneous speed can be very different to the average speed, and it's important not to get those two confused. So now we've been talking about speed, and we're all well established on speed, and we know what's going on, and we understand it, and that. Now I'm going to throw a spanner in the works and make it all the more difficult by asking you what is velocity. So we're going to go back to what we did with speed, and we're going to ask, what do you need to measure the velocity? Now I'm sure that you've all heard of the term velocity and things like that. So um, it's going to sound very familiar, and you might say, well, to measure velocity, you need a measure of length and a measure of time. Well, that sounds really familiar. That's exactly the same as what we did for speed. So you could ask yourself when you're asking what is velocity, is it the same as speed? Well, if it was the same as speed, then we wouldn't need to have two different separate things, would we? So clearly it can't be, but there's got to be some kind of specific difference. So we need to know how velocity is different to speed. Does anybody have any ideas? Have a think about it. So the definition of velocity is the displacement of an object in a given amount of time relative to a point. Now you might think that this definition sounds really similar to the definition of speed. It does, and it is pretty similar, but there is a distinctive difference. So the key word here that's different, you may have noticed it, is displacement. Now the time part is the same, the relative part is the same. It's the displacement that makes that is the difference between velocity and speed. So you need to understand exactly what is displacement and how it applies in this scenario. So the displacement is the distance from the origin, from where you started to where you ended up. It doesn't take into account the path that moved. All it looks at is which way you went, and therefore it has direction, and where you start and where you end. Now, because it has direction, it means that the displacement can be either positive or negative. This is the key difference between velocity and speed, is that one was a scalar, the other is a vector. So let's have a look at how displacement differs from distance. Now we started off with the blue object and it travels to the right, and you can see it has a displacement which was the same as the distance. Now in the second example, it travels to the right and then back to the left. Now last time the distance was the sum of how far it went to the right and then how far it came back to the left. But this time it's just how far it started from, and you can see there's a considerable difference there between the displacement and the distance. So to find the velocity, we look at the displacement divided by the time taken. And to find displacement, because it's a vector value, we look at the final position and subtract the initial position, xf minus xi divided by t. So it's the change in x, which is the delta x, over the time taken. Now velocity is significant and it's the one we use, and it can be negative or positive. If we're doing this in one dimension, then the displacement we would consider to be x. If it was vertical, we would say the displacement was y, but it would be the final minus the initial displacement divided by the time taken. So as we know that speed and velocity are both a measure of length and a measure of time, the units are a ratio of distance divided by time. The SI units for speed and velocity are meters per second. Those are the ones that we are going to use most of the way through this course. Sometimes we will use other units, and sometimes we will need to convert units from one to another. That's a subject of a different video. Okay, thanks for watching.